All right, so this is a recording of the answers to the final exam. We have question number 1 here on the screen, and I'm going to do it, kind of like on a piece of paper, except it's on my tablet. So the way we start this is, we can start with it line by line, and we can see how there's line 1 over here. So that means the main program or the main function is on line 1 because that's the entry point of the entire program. So I'm going to put int main open and close paren because that's how we start the definition of a function. So whether the brace is on the same line or not, we can decide that later. We also see that on line 5 here, that's when we update local variable x to a value of 3. So that means we know that line 5 is going to look like x equals 5. That's the easiest way to change the value of x to a 5. And we can now see that there are 3 lines in between, which basically means the definition of local variables with use of these 3 lines. Okay, so you can use int x on one line, int y on one line. Oops. Okay. Int. Oh, okay. I thought my funky looking glove is going to help me so that I don't accidentally register as a touch on the bottom bar of the tablet. And it doesn't work all the time. Sometimes it still registers. Alright, well, I just have to be careful then. Alright. So that takes care of the first 5 lines, and then line 6 is changing y to a 1, and then line 7 is changing z to a 1. So now we kind of know what to do with those. And let me get the bottom row out. There we go. So now we can actually write. So now we have y, oops, okay. So y equals 1 goes here, and then z equals to 1 goes here. Okay. All right, so now we get to line 8. We can see line 8 has a condition to evaluate. So that means we are so at this point we have to kind of figure out of the 3 control structures that can have a condition to evaluate, which one is this one. In a do-while loop, when we evaluate a condition, especially when the condition is true, it goes back to a previous line. But we can see that even though the condition is true here, it goes to the next line. So that helps to rule out a do-while loop. Now we are down to only 2 potential control structures. One is a conditional statement, if, and the other one is a while loop, which is also called a pre-checking loop. In the case of a pre-checking loop, when we get to a bottom, it would go back to the first line. It's kind of like this transition from line 11 back to line 8. In the case of a conditional statement, on the other hand, it never goes back. So now we know this is a while loop because we have ruled out the other 2 conditional statements. So this part is going to get a little bit messy just because I cannot scroll the screen like a normal PDF reader. So now we have while, okay, and I have to go back to while x is greater than 0, do the following. So I typically put an open brace here, so if we see that it should not be there, then we'll fix that. Alright, so from line 8 we move on to line 9. And we can see how y is changing over time. It goes from 1 to 2, 2 to 4, and then 4 to 8. So that means we are doubling for each iteration. There are 2 ways to do this. One is to multiply by 2, and the other one is to add the value of y to itself. So both are acceptable solutions. So I'm just going to use the more obvious answer, which is y equals to 2 times y, like so. And now we look at the next line, which changes local variable z. So it changes it from 1 to 3, and then 3 to 6, and then 6 to 6. So the pattern here is the multiplier of going from 1 to 3 is a 3. The multiplier from 3 to 6 is a 2. And the multiplier from 6 to 6 is only a 1. So that would also be consistent with the value of x. Because x is a 3 here, 1 times x is going to be a 3. X becomes a 2. 3 times 2 is a 6. And now, x becomes a 1. 6 times 1 becomes a 6. So that is the correct solution. So let me just write that down. So z becomes x times the current value of z. And now we move on to the next line, which updates the value of x itself, which is on line 11. And we can see how that is just kind of decrementing by 1 every time. It went from 3 to 2 to 1 to 0. And if we focus on just line 11, it changes it from 3 to 2, and then 2 to 1, and then 1 to 0. And the easiest way to express that is it is just decreasing by 1. So x gets x minus 1, semicolon. And we can also see, right after line 11, it goes back to line 8. So that means line 11 is the last statement of the while loop. And we also see that, once the condition of the while loop is false, it does not go to line 12. It goes straight to line 13. So that means line 12 is, right. So line 12 is most likely just an AND brace here. And then line 13 is a return 0, because when we get to return 0 in main, we conclude the execution of the whole program. Line 14 is going to end the brace that we use to begin the entire thing. So that's for question number 1. And the way I'm going to grade this is I'm going to look for basically the construct in the code that corresponds to transitions in the trace. So any answer that reflects an understanding of, okay, this transition of the trace suggests, this is the code in the C code, in the original C code, that would get people points. So that's how this is going to be graded. It will be separated into many parts, and each part is going to have its own grade. All right, so moving on to question number 2. So question number 2 is a little bit more complicated, and to trace this, to kind of mark the answer is going to be a little bit more difficult to do, because it would need a lot of back and forth here. So first thing first, we can see that it starts with line 1. So that means your main is starting on line 1, because that's how we start the execution of the whole program. So so it's not preventing my touch on the bottom bar here. Well, let me see. I think I can change some of the preferences and not to interpret a touch to the bottom bar for anything. So we go to gestures, page number bar, double tapping. I might need to go to a more general setting in order to change the behavior of this code. Not code, but of the tablet. All right, well, we'll see. Okay, so I'm just going to use, so we have int main open close paren. Most of the time I put the open brace on the same line, so I'm just going to keep it here. Now, this time we see that we have 4 variables in main. One is array A, it has 5 elements. One is local variable I, one is local variable M, and one is local variable N. And the first line that actually does anything is line 6, which changes M to a value of 5. Okay, so the way we are going to do this is to skip to line 6 and then just say that on line 6, we have m equals to 5. So now we can see that there are 4 lines in between, and those 4 lines will be used to define the local variables. So we have, and the order is not even important in this case. So, in the original code, I have array A defined first, and this is how we define array A and give it initial values to begin with. This particular construct was used in a homework assignment. And we can see that the values of A is 5, 1, 6, 5, 1, 6, 8, 4, 5, 1, 6, 8, 4. There we go. So we have 5, 1, 6, 8, 4, close the brace, and then with a semicolon. And then we have the additional local variables I, m, n afterward. And with 3 lines here, you can afford to have 1 line for each one of those variables. So we have int I, int m, and also int n over here. Now, if you want to kind of collapse all these definitions on one single line, that actually works too. You can leave some empty lines in the program if you put multiple definitions of variables on the same line. All right, so after line 6, we have line 7, which initializes I to 1, and then line 8 initializes n to 5. Okay, so we'll go ahead and do those initializations. Okay, I equals 1, and then n equals to 5, like so. All right, so at this point, m equals to 5 is okay. It is consistent with what the code does. But you can also see how the first element, or element 0 of array A, is also a 5. So that's actually the original code is m equals to a bracket 0. So I'm just going to put here and suggest that the alternative here is m equals to a bracket 0. So either one will be considered correct. The first one, the left-hand side, this one here, is more intuitive, and then this one here is actually what the code has. But it's okay, because I did not disclose the purpose of the code, so it would not be possible for anyone to know that the correct answer, the intended answer, is the second one instead of the first one. So I'm not going to take points off if people just say m equals 5. That's fine. All right, so let me go back to the previous page, and it jumped a few pages more than what I need. Okay, let me see. Just go back by 1 page. Nope. Okay, there we go. All right, we're back in business. All right, so now we have line 9, which is also evaluating a condition. So now the question is it a while loop or is it a conditional statement? And the answer is it is a while loop, because we can see how line 9 is here, and also here, and also here. And every single time we get back to line 9, it's coming back from line 13. It's coming back from line 13, coming back from line 13. And also, the last time we get to line 9, the condition evaluates to false, and then we skip to line 15. So all of these are basically confirming that line 9 is the beginning of a while loop, because a conditional statement does not go back from the bottom back to the top. So that's the reason why we know that line 9 is going to be the beginning of a loop, which is a while. And let me go back to take a look at the condition. I is less than n. Okay, so while I is less than n, and then I typically put a curly brace on the same line. Now we move on to line 10. Line 10 evaluates its own condition, and when it is true, we fall through to line 11. When it is false, it skips to from line 10 to line 13. So this tells us that it is a conditional statement. Because if line 10 was a loop, then we would also see, somewhere here, it would go back to line 10, but we do not see that. So that means line 10 is not a while loop. instead it is a conditional statement. So we'll go ahead and just write down if a bracket I is less than m. Okay, so we'll just write that. So now we say if a bracket I is less than m, and we do something. All right, so we already know the then statement is ending on line 11. Okay, that's the last line because it skips to line 13 afterwards. And if the condition is false, it goes straight to line 13. That means there's no else statement in this case. Okay, so now we can go back to the code here, and then we just put a close bit brace here, and now we just have to backfill. Okay, what if the condition is true? If the condition is true, we execute line 11. And line 11, there are two instances of line 11 executing. The first time it updates m to a 1, and then the second time it updates local variable m to a 0. And it coincides with the value of I. So when I equals to 3 and a bracket 3 is a 0, it puts a 0 into variable m. When I has a value of 1 and it does update, it puts a value of 1 here, but we can also see a bracket 1 has a value of 1. In other words, the update of m seems to be using a bracket I for the update. So now we kind of fill that in. So we say m equals to a bracket I. All right, so now we move on to line 14 and see what line 14 is going to do. There's no line 14, that's only line 13. So when we go to line 13, we can see how I increments from 1 to 2, how I increments from 2 to 3, how I increments from 3 to 4, and then finally from 4 to 5. So line 13 appears to be just incrementing I. So that means we express that as I gets I plus 1. And that's the last thing we do in the loop. When the loop is done, when the condition becomes false, we go straight to line 13. Oh, wait, hold on a second. When I is less than n is false, okay, not, so I pointed the wrong line. So when the condition of line 9 is false, we go straight to line 15, and then we get to post. So that means line 15 has to be the return 0 of main, and this is going to be the close brace at the very end. All right, so that's for question number 2. And then for question number 3, we start to have functions. So the first thing we do is we analyze, okay, where do we start the execution of this code? The first line is on line 10, and also we create a local variable x at that time. So that means that tells us that main starts on line 10, and it has a local variable definition of x. So let's skip to line 10 and then start to write there. So we have int main open close paren open brace. On the next line we have int x, which defines the local variable x. So now we took care of all the way up to row 4. On line 12, we see that we allocate a column and then we label it return. So that means we're calling something on line 12. Whatever we're calling is replaced by a single question mark, and the rest of the line is preserved in the return column. So this is telling us that line 12 is a very simple assignment statement to update x, and whatever is on the right hand side of the equal is the calling of a function. But since we don't see any additional columns being used here for parameters, so that is telling us that whatever function we are calling here does not return, does not have any parameters. And since we cannot really tell what the name of the function is, we can just call it mystery. Okay, so we'll call it mystery and update line 12 so that it is now just x equals 2 mystery with no arguments. Okay, So that takes care of line 12. And then when we get to the mystery function, okay, it is on line, it's on line 7. So now we go to line 7, and then we say this is the beginning of the mystery function. And because x is an integer, we can see that x always has integer values, because when you look at the column corresponding to x here, it ends up with the value of 12. Now, if you use double, I'm not going to mark it wrong, but since integer is the simplest type that can handle this, we'll just say it is an integer then. So we have mystery here, and then we'll see what it does. So when we get to mystery, it goes straight to line 8, and on line 8, it is calling another function. And so line 8 is a return statement itself. The left-hand side of the plus is a question mark, which means it is a function call. And then the right-hand side is a call to Johnny. So that means line 8 is making a call to yet another mystery function. So we'll call that mystery 1. And now we can fill up line 8. And line 8 is a return statement itself. And then the left-hand side is a call to mystery 1. And then the right-hand side of the plus is actually spelled here. It is called Johnny. Okay, so we'll say Johnny over here. And then we close brace over here, because after a return statement, there's no way to continue execution after a return statement. So that's mystery itself. And when it does call the mystery 1 function, we can see the mystery 1 function starts on line 1. So now we go to line 1, and then I keep scrolling back to the wrong page. Okay, so on line 1, we now have mystery 1 as a function. Now, obviously, if you call this something other than mystery 1, that's fine too. But let's see what line 1 does. Line 1 is just the beginning of a function. It doesn't do anything else. Line 2, on the other hand, is copying and pasting the returns cell. So that means it is a return statement itself. So we know right away that line 2 is a return statement. The question is, what is it returning? So in the return statement, what it returns is marked by how the question mark changes to something that is not a question mark. So that's telling us that in this case it's returning a value of 7 for whatever reason. Okay, and that's the end of mystery 1. When mystery 1 return back to mystery, then we call again. So because on line 8, the second time we use line 8, or we encounter line 8, it is simply saying, okay, we know the left-hand side of the addition is a 7, but the right-hand side is still Johnny. So that means the next line that we need to execute here on line 4, that's for Johnny. So that means Johnny starts on line 4. And then on line 5, it copy and paste the return cell, changes the question mark on the right hand side of the plus from a question mark to a 5. So now we know it is a return 5 here, and then close brace. And that concludes the reconstruction of the code for question number 3. Now we move on to, there's a little bit more. Because even though we figure out all the mystery functions, main still needs a return 0 over here and a close brace over here. Okay, now it is done. All right, so now we move on to the more complicated one. And so in this case, main is starting on line 14. Main itself has 3 variables. It has array A, which has 3 elements. They are initialized to 6, 1, 4. And then it has 2 variables, n and x. N and x end up only with integer values, so we know they are just integers. So now we go to line 14 to start main. Okay, so we'll go ahead and go to line 14. We say this is the beginning of the definition of main. It has a local variable a, which is an array, and it is initialized with the three values of a, which is 6, 1, 4 over here. So now we have 6, 1, 4 in braces. It has two additional local variables. They are n and x respectively. So I keep scrolling to the wrong page. So we have n, and then we also have x over here. All right, so we are now down to line 18. So line 18 changes n to a value of 3. So we'll just go ahead and specify the simplest code that can do this, and just equals to 3. And then we move on to line 19. When we get to line 19, we can see that some additional columns got allocated. So that is indicative of a function call. Now this time, before the return column was allocated, we also have b, I, and n. So those must be arguments, or they are parameters of the function that is being called. The function being called is on the right hand side of the assignment. So on line 19, it is x equals to a mystery function call with 3 arguments. So we'll go ahead and write that down. Okay, so this one is x equals to a call to some kind of a mystery function. It has 3 arguments. The first argument, only leaves behind that it is a reference of column C. And we can see that column C is the start column, or the first column of an array. Now there are several ways to interpret this. Okay, it can be just we are just passing a bracket 0 by reference, but we can also see how reference C, reference C, reference C are all passed here. So there are 2 possibilities. Either we are only passing an integer by reference, or we're passing an array. So at this point in time, it's not entirely easy to kind of know which one it is. So we'll go ahead and I keep scrolling back to the wrong window. All right, so at this point, we'll just kind of give it the benefit of the doubt and say that okay, it could be either one. And we can see that after the columns are set up, we proceed to line 1. So line 1 must be the beginning of the mystery function. And we can also see that when it returns a value of some kind of an integer. So the return type is also an integer. So now we can see that we can determine that mystery has a return type of an integer, and it has 3 parameters. For now, we're just going to say, okay, let's just assume that it is passing an array by reference. So it is array B, because B is the name of the column, and the square bracket means we are passing an array. And then we have the other 2. The second one is I, and then the third one is n. So we have I, which is an integer, and we also have n, which is also an integer, because we can see pretty clearly, okay, that both of these are integers, both of these are integers, both of these are integers. All right, so now we skip to line 3, and oh wait, there's a little bit more. We can also see that a column called M is allocated on kind of when line 1 executes. So M is a local variable of the mystery function. So now we just add that we have a local variable M here, and now we move on to line 3. On line 3, when we get to the execution on line 3, we have a condition here that says I equals to n minus 1 is false. So now once again, we have to determine, do we have a loop, or do we have a conditional statement? So this looks a little bit confusing, because it looks like a loop, because it looks like we get back to line 3, we get back to line 3, we get back to line 3. But we can also see that every time we get back to line 3, the context of the columns is different. Like when we execute this line 3 here, it is using the context that's already established, which is this part here. When we get to line 3 over here, it is using a different context. Okay, so that means, even though we do go back to line 3 repeatedly, it does not appear to be the work of a loop. It is a conditional statement. We can also see that how when the condition is false, we skip to line 6, but when the condition is true, we continue on to line 8 over here. So that means, we have a conditional statement, and okay, so let's continue with the trace. We can also see in the trace, after line 6, it continues on to line 7, and then after line 7, it is going to line 10. Let me see. Okay. So it is a conditional statement, but it does not have an else. The reason why it does not have an else on the condition that starts on line 3 is because when it is false, it goes to line 6. When it is true, we go to line 4, and then we still go to line 6. So that means line 6 is not, well, this is after it returns. We get to line 4, and line 4 is returning right away. And we have line 6. All right, so this is a little bit tricky because it can be an else. It can also be without an else. I'll explain why that is the case. So what we do know is on line 3, we have a conditional statement. The reason why we know it's a conditional statement is we do not go back on that line when the context is staying the same. So now we know it's an if, and we also know the condition of the conditional statement. It is I equals to equals n minus 1. So we have I equals n minus 1. Okay. And then we move on to the next line. So line 4 is, the only time we get to line 4 is over here. And we can see that on line 4, it is, oh, this is the part when I made some changes in the class. I shifted everything down by 1 row, and I also added more to the right-hand side. So this is where we can see what it is actually returning. So the return cell is changed, and I cannot remember how I fixed that in class because I did fix that in class. Let me see. I think I have it recorded on my phone. Give me a second to look that up. All right. Well, I thought I made a screenshot. Yes, I did. All right. So when it does return, it's changing m equals to question mark to a 4. So it's returning a value of 4. So that means, so what I'm talking about is there's a return column here. And that return column has m equals, line 6, m equals to question mark. And then on line 20, it changes, or line 21, I should say, it changes the return column to m equals 4. But we cannot just say that. Now, in this case, we can claim that line 4 just returns a value of 4. Okay, so that is actually okay. So we can say that when this is true, it returns a constant value of 4. But that's not exactly what it does, but we'll just say that that is the case for now. So now onto line 6. So line 6 is an interesting one because we could use an else here, or we can just say it is a direct return statement. But in either case, what is interesting about this return is every time it returns, it is returning a value of 1 on line 6. And the reason why we know that is because okay, so we have line 7. Okay, so I need to be careful here. All right, so when this returns, it returns to line 6. Line 6 is m equals to whatever the return value is. So that means on line 6, it is, okay, so I got it wrong. I do apologize. I was jumping a little bit ahead of myself. So on line 6, it is a statement that involves changing m, because we can see how when we put the entry into the return column, it is saying m equals to, oh, okay, I forgot to change the tool. There we go. So m equals to some kind of a function call. And the function call is mystery itself. This is where it is doing things recursively. So we know it is mystery. And when you call mystery, you have to give it the arguments. So this is so once again, we do not yet know whether it is passing a single integer by reference or it's passing an entire array, but we know that it's passing I plus 1 here. The reason why we know it is passing I plus 1 is because when you look at how parameter I changes, the first one starts with 0, and then it's a 1, and then it's a 2. So that means every time we call mystery recursively, I is incrementing by 1. We can also see, in the same pattern here, that n doesn't change. N is 3, n is 3, and it's also 3 over here. So that means n is just passed as itself. So now we have n over here. All right, so that's line 6. And then line 7 is also a conditional statement. And now the question is, is it nested in line 6 or is it not nested? When line 7 executes and it is a false, we skip to line 10. And now we have to figure out, okay, what if it is not false? If it is not false, then it continues onto line 8. And then line 8 is itself a return statement. So that means line 8 is a return statement of some kind. Okay. And line 7 is it's either a conditional statement or a loop. When the condition is true, we go to line 7, then we go to line 8, but we do not go back to line 7. So that means line 7 is a conditional statement. So now we know this is an if. And then the condition is b bracket I is less than m. Over here. And I typically use curly braces regardless of whether it's needed or not. So right now we just confirmed that parameter b is being used as an array. So that confirms that the using b square bracket as the definition of the parameter b was indeed correct. So now the question is, what exactly is it returning? This is also a tricky one, okay? But it does make the answer a little bit easier, because every time we get to line 8, okay, every time we get to line 8, we can see that we change the question mark to a 1. This is the first time we do that. Okay. So now based on this, you can say that, oh, okay, maybe we just return a constant of 1 here. Okay. We can also see line 9 does not appear anywhere in the trace, so more likely than not it is just a closed brace here. And then we also have line 10 being a return statement of some kind. And we only get to line 10 when the condition of line 7 is false. So now the question is line 10 the else part, or is it not an else part? Well, at this point, we'll just say that it is not an else part. And we can also see every time we return from line 10, as far as we can tell, it is returning a value of 1. So we can also just kind of put a return 1 over here. After line 10, there's no trace of line 11 or 12 or 13 for that matter, because when you look at all the line numbers here, all 3 are missing. So we know that we need 1 line, okay, or typically what I do is I use 1 line over here to close the brace at the beginning of the entire function definition. So now the question is, what about the other 2 lines? The program or the code as it is right now is actually not entirely correct, because even though we know what values are being returned here, we are not taking into consideration of how the columns get constructed. So we can see that on line 6, columns are constructed. On line 6, columns are constructed, and not so much on the other lines. So on line 8, okay, we can see that line 8 does not construct new columns. In fact, yeah, and then also on line 10, it also does not construct new columns. So that tells us that line 6 is, well, okay, we already got that done, so it is correct here. And as far as we know, this code here is now consistent with the trace, and so anyone who kind of produced this particular code is going to get full points already. The actual code in this case is when I equals to n minus 1, it returns the element. Okay, so this is the actual code here. It returns b bracket n minus 1. That is what it actually does, because oh, I take it back, sorry. Well, okay, either case it is correct, but the actual code is not quite like this. Okay, the actual code is, it simply returns b bracket I, which is the last element. But you don't need this answer to get full credit. If you just say return 4, you're going to get full credit. And in the case of line 8, it also does not just return a constant of 1. It returns okay. Let me check. It returns a b bracket I itself. So in this case, it returns b bracket I, and we'll see whether that is consistent or not. And the way we do that is we take a look at when it executes line 8. Okay, when it executes line 8, it returns a value of 1. So now the question is that 1, is this 1 over here indeed reflecting the first element 1 of array B? So the context of getting this 1 here, thinking that it is b bracket I, is based on this I and this B over here. If this is B, okay, it is a reference to column C, which means column C is now seen as the beginning of an array, and I is the element of that array, which is actually a 1. So it is consistent with what I specify here. So that leaves the last question of what is this return 1 supposed to be on line 10? Because on line 10, we can see we also just return the value of 1. So as it turns out, in this case, it is actually returning m, okay? And we want to see if this is correct or not. So when we execute this line 10 over here, m is already updated to a 1 by the time we get here. So that means this is actually also consistent with the trace of the code. But this part of the answer is not needed in order to get full credit. If you give me something like this, you're already getting full credit. And actually, in the original code, there's also an else here, and an open paren, and then a close over here, and also there's another else over here, open brace, and then close brace here. But once again, those cannot be implied by the trace, so that means I cannot use that for grading purposes. So that means when I grade this particular question, I'm going to roll back all the things that cannot be implied as a result of the trace. So I'm just backtracking all the changes because those cannot be implied by the trace. There we go. Okay, so this part can be implied by the trace. All right, so for the most part, the most important part here is the recursive call. Okay, is to figure out the recursive call and to figure out the parameters here. And after this, okay, we have one more task to do, which is to backfill line 19. So we are passing array A from main as parameter B. We are, okay, so let's go back to the trace here. So we are passing a 0 as I and a 3 as N. So we have a 0 here and a 3 over here. And then on line 20, we deallocate everything. So that means line 20 has to be the return 0 of main. And then after that, we have a close brace, and we are done. All right, so that's pretty much the answer to all 4 questions in the final exam.